right. Hey, AP kids. So let me show you how to make the formulas here in this thing. And I've never done a QuickTime Player, so fingers crossed this works. It's just an audio file. But over here you have your absorbances. And by the way, I'm pretty sure those don't go there. Let's move those down a minute. So I'm going to start in this first box, C4, because that's where I'm going to put my first equation. Now, when we did the calibration curve, y equals mx plus b meant absorbance equals slope times concentration. We can ignore b because it was pretty much zero. So how do you find concentration? It's going to be y divided by the slope. Well, y is absorbance divided by the slope. So you're going to start typing with an equal sign. That tells us it's a formula. And you're going to do $B4 because that's where my absorbance is. The dollar sign is going to let us copy this formula over and over again and change that absorbance. If you just put in B4 divided by whatever, you're going to get the same answer all the way down. We don't want that. Divide is the slash button. It's also right next to the shift with the question mark. And then put in your slope from your calibration curve from the first day. And when you hit equals, you get that. Now, sometimes it'll automatically populate, but I think it's because I've messed this up enough times it's not going to. Shocking, I know. So copy, paste, and now I can go ahead and do paste values. Well, I don't know. Let's try paste values only. Nope, that wasn't it. Sorry, you guys. Copy, paste. Let's try. No, never mind. There's a way to make this go all the way down, but I'm not sure how to do it again. I think you have to click and highlight or something, and then it'll keep going. But there is a way to make it go all the way through. And I bet if you didn't mess up the first time like I did, it would have worked better. But I keep messing this up. So that's the first one. The first formula simply equals dollar sign B4. And if you didn't start till 40 seconds, it's going to be B5, whatever that first absorbance is, divided by the slope from the calibration curve. So how are you going to do natural log? A little different. Equals. Now this is the natural log of the concentration. The easiest way is to get the natural log thing. So I'm going to come over here to functions, and I know you can do it for maybe data. I think data lets you do it too, but I'm going to go over here, functions. Come down to all and scroll way down to ln. ln is natural log. Oop, I went too far. All right, right there. Automatically gives you parentheses. So I want to take the natural log of the concentrations. In this case, dollar sign C4, because that's the box I want. Hit equals, and then you should just be able to copy that and paste. And I'm going to see if I can get this to work. Paste. Hey, it worked. Who knew? In this last one, we need to do a little bit of a different formula. Now I'm going to play with this as I type to make sure. I might mess this up, but equal sign. 1 divided by, use parentheses here, dollar sign. This time we still want to do the concentration. So we want to go back and take C4, and equals. And I'm just going to double check my numbers. That looks right. And I'm going to copy that. I'm going to highlight all the rest of this junk, and I'm going to hit paste. And of course, those didn't work for me because I have no values there because I was too lazy to type them all in. And that is how you get all your data. And then you're going to want to make several graphs. You want to do, as I flip through my notebook here, you want to do absorbance, this versus time. Okay, time is always going to be on the X. So always highlight A first, and then remember, hit Control, Command, whatever you're working on. I'm on a Mac. And that. And then you're going to graph that. You want to do a scatter plot on all of these. And that looks kind of funky. I would probably go in and adjust my margins here. But it's also because I don't have a full set of data. If you do this, it's going to look a lot better, just trust me. So you want to do time versus absorbance, time versus concentration. It's late, you guys. Time versus natural log, time versus the inverse. And then you're So you're going to have 4 graphs. You're looking for the one that gives a straight line. In this case, it's going to be a negative slope because it was decreasing, but a straight line. And that's going to be either 0 order, first order, or second order, as we talked about. And then when you come down here and you do this set of data, again, that's how you do all the equations, you only need to do the one graph that gets you the straight line. So whether that was concentration, natural log, or inverse, it should be the natural log, hint, hint. That's the only one you have to do here. And make sure you get the line equations for both of them, because the slope of the line is your rate. So for crystal violet, it should be natural log, therefore first order. And when you do your two for the 0.02 molar and the 0.01 molar, you're going to get those slopes and you're going to compare them. So when you went from 0.01 to 0.02, you doubled the concentration. What did the rate do? And you should be able to get that from the data. And just to spoil the surprise, when the concentration doubled, the rate should double. So they should both be first order. See if your data can support that. Let me know.